In this lesson, we're going to learn how to take the equation of an ellipse that's written in general form and convert it to standard form. Now, all we really need to know is that we need to complete the square twice at most, maybe once, maybe not at all. Hopefully you don't have to complete the square at all. But this is the most complex that you'll see, where you have to complete the square twice. The first thing I'm going to do is I'm going to rearrange it, grouping the x terms together, grouping the y terms together, and bringing this term that doesn't have a variable to the right side of the equation. So here's the new equation I've written. Again, notice my 7x squared's here. I brought this negative 28x next to it. The 9y squared came after. The 18y is next to the y squared. And then that negative 26 I brought to the right side of the equal sign, making it positive. The next thing I'm going to do is, in order to complete the square, I cannot have a leading coefficient in front of the squared term. So I need to remove the 7, and I need to remove the 9. Now, you could technically divide everything by 7 and everything by 9, but that's going to make it really messy. So what I recommend is you factor out a 7 from the 2x terms and factor out a 9 from the 2y terms, and you'll get an expression that looks like this. Ta-da! So now, if you'll notice, all I did was I factored the 7 away from the x squared, a 7 away from the 28, which leaves a 4, a 9 from the y squared, which leaves the y squared, and a 9 from the 18y. Now I'm going to rewrite this, and I'm going to leave a space in the parentheses for a third term so I can make a perfect square. So now I'm going to leave a space and rewrite it, and it will look like this. Ta-da! So now I have the space for a third term that I need inside the parentheses. So what I need is I need to remember, what must this third term be? Well, remember, it's half this middle term squared. So I take half of negative 4, which is negative 2, and I square it. And I always get a plus. So I get a plus 4 here to make these three terms a perfect square. I come over here to the y terms. I take half of the 2, which is 1. I square that, and I add in 1. Now, we need to slow down for just a minute. I added some extra values into the left side of the equation. I better add them to the right side of the equation. Try not to look at that 93. So I'm going to add some more to the 26, but be very, very careful. I don't add 4 and I don't add 1, because think what would happen if I distribute this 7 back in. This 7 times the 4 actually means I added 28 into this expression. And the 9 times this 1 actually means I added 9 into this side of the equation. So I need to add 28 and add 9 to the right side of the equation, to this 26, because that's actually what I ended up adding into these two parentheses. I added 4 here, which when I times by the 7 on the outside is 28. I added 1 here, which when I multiply by the 9 that's on the outside is actually 9. So I added a 28 and 9 on the left side of the equation. I need to add 28 and 9 on the right side of the equation. Now these two are perfect squares. I can write them as binomials squared. I hope you remember how to do that. So I'm going to write those as binomials squared. And when that's done, oh, by the way, I'm also going to add these three numbers on the right side. Ta-da! And then when I've done that, right, this trinomial factors to an x, ooh, there shouldn't be a squared there, sorry, to an x minus 4 squared in parentheses, x minus 4 in parentheses squared, with the 7 on the outside, plus in parentheses a y plus 1 in parentheses squared with a 9 on the outside, and then the 26 plus the 28 plus the 9 is 63. Now I have one last step to get it in the right form. I'm going to divide both sides of the equation by 63. And if you always like, how do you know to divide by 63? Well, we always want the right side to equal 1. But now I divide this by 63, and I divide this by 63, which these will always hopefully reduce. 7 goes into 63 9 times. 9 goes into 63 7 times. So when I actually reduce that, you won't see a number in front of the parentheses. You'll just see a number underneath the parentheses. And you'll get a final solution that looks like this. Isn't it cool how that just magically appears? But anyway, if you'll notice, I have my x minus 4 squared over 9, y plus 1 squared over 7 equals 1. 63 divided by 63 is 1. This is my ellipse written in standard form. I know the center now is at 4, negative 1. My major axis, half its length is 3, because remember, I have to square root the 9. It's 3, so it's the whole length of the major axis is 6. The minor axis, I'd have to square root 7, which is fine. I've typed them in up here. Let's see how well I did. I did something wrong. X minus 2 squared. Oh, that's odd. Does everyone see where I made my mistake? I see where I made a mistake. Half of negative 4 is 2. I even did it over here. That should have been a 2. That should have been a 2. I actually went back to the 4. I did do half my 2, which is 1, right? Everything else is correct. 9 plus 7 equals, I forgot, remember, the number that goes inside the parentheses is half this number. The number that goes inside the parentheses is half the number that sits in front of the single y term or single x term. Hopefully you caught that mistake before I even did. Again, this is probably the hardest you'll see. Hopefully you won't have to do that with all of them. In other words, if you don't have a y squared or an x squared term, what I mean by that is if I go back, I know some are much, much easier than that. Like this one here, just divide both sides by 28 and you get your final solution. There's no need to complete the square because there's no x term and no y term. It's x squared over 28 plus y squared over 4, because 7 over 28 reduces to 1 over 4 equals 1. So if there isn't that second term with the x, you don't need to do anything with it. If there's not that second term with the y, you don't. But if one of them had it, then you need to complete the square on the 1 and then divide over. If you have questions, please bring them to class.